Okay, let's talk about different kinds of variables for a second. My background is I'm basically an overachieving high school math teacher. I just didn't know when to quit. So when I was teaching math and we're talking about variables, I might have something like x plus 3 equals 10. X is the variable. Again, this is one of those what does it sound like questions. The word variable sounds like the word vary. Vary is going to be a vary is going to be a very important word in this course. A variable is something whose value changes or might not be the same from one situation to the next. If in my equation x plus 3 equals 10, x is 7. X isn't always 7. It's always going to be 7 in this problem, but it's not going to be 7 necessarily in some other problem. So variables in research are things that change, that are different from one situation or often from one person to the next. For example, if I'm talking about just some nominal stuff, and I say gender, it's going to be male in one case, female in another case, and about all you can do is count how many of each you have. Okay, so I may have a column identifying each of our responders by gender. So that column, you'll see when we get into SPSS, a column essentially will represent the values of a variable. Now there are a number of ways to classify and think of variables. One is, and I'm, if you want to follow along on your hymnal, page 14. There are discrete and continuous variables. Discrete variables don't run together. I love the definitions they give, so I'm just going to insult your intelligence by read this. A discrete variable consists of isolated numbers separated by gaps. Well, that's not very helpful. But if you look at the example, if you look at the number of children in a family, families of size 1, 2, 3, 4, whatever, that's discrete variable because you don't have the fractions between there. You don't have half. Now, you might have the average family size, maybe 2.5 children, but you don't have any families that are, you're not going to have 2.5 by any family in that column for the variable. It's kind of like, well, anyway. A continuous variable is a variable that kind of runs together. You can have those fractions. For example, I used the example of weight a minute ago. Weight is continuous because, yeah, you have 1 pound, 2 pound, 3 pounds, but you can also have any fraction between there or any decimal number. So weight is continuous. You don't just kind of jump, you don't have to jump from one value over something that doesn't exist to the next value that does exist. So continuous and discrete are two different kinds of variables. Another way of classifying variables, this is going to be more important to us, is independent and dependent. Independent and dependent variables. Page 16 is another non-helpful definition. Of course, I'm going to read it to you. In experiment, an independent variable is the treatment manipulated by the investigator. The dependent variable is the variable that is believed to have been influenced by the independent variable. Okay, let me make a couple disclaimers first of all. In this kind of research, there are things it can do and things it can't do. One of the things this kind of research cannot do, our kind of research cannot do, is to determine causation. Let me give you an example. And I'll give examples of independent and dependent variables too. I've got two different kinds of teaching method. Method A and method B. Let's be real imaginative and creative. Method A and method B. And my outcome is I'm going to measure test performance. Test performance is the dependent variable. Teaching method is the independent variable. Method A and method B. Right? Yeah. And then test score at the end of it. So the method is the independent variable. The outcome is the dependent variable. Independent comes before dependent. Now here's the problem with that, and this is a problem in educational research in general, and that is back to this idea of causation. I can tell if there's a difference in test scores between X and Y, classroom X and classroom Y. How do I know that difference is because of the teaching method? In order to determine causation, a number of things have to be true. Well, the independent variable has to happen before the dependent variable. Okay, we divide them, we teach them differently. We can handle that, right? So that has to be true. The big thing that has to be true is if there's a difference, you have to be able to say that nothing besides the independent variable caused the difference. Oh, that's a problem. Yes, we can determine if there's a difference in the test performance of classroom X and classroom Y, but we can't determine that it's because of the way that we're grouping them together. Now, in true experimental research, and you've probably run across this, true experimental research means that your subjects are randomized in a couple of different ways. They're randomly selected for inclusion in the study, and they're randomly assigned to, one of two or more groups. You can't do that in education because classrooms are already intact. So maybe X classroom was higher than Y was in the first place. I don't know. I could eliminate that. I could test for that. But how can you possibly think of every possible cause there might, and you can't. That's the example you can. Now, even things like some things you can control for and some things you can't control for. I'm going to teach them two different ways. Can you think of some things that you might control for or that you might not control for? For example, how do I know it's not the teacher his or herself? Might just be one teacher's better than another. I can fix it. How can I fix that? I'll have the same teacher. Not the teacher that's the difference, got the same teacher. What have I caused? What have I caused to happen now? What's another variable I've just introduced? No, it's the same. You've got the same knowledge. You're the same teacher. I can't do them both at the same time. Time of day I've introduced as a potential confounding, and that your book used the word confounding variable. It might be time of day is going to account for part of the difference. So I can't control everything. So that's part of why this kind of research, and I'll smack you on the hand if you use things like the word caused or influences or any of those causal words. I'll also figuratively give you a little love tap if you use the word prove. Because of these kinds of things, our kind of research does not prove anything. It tells you if there's a difference, but it doesn't tell you why there's a difference. It can't tell you what accounted for. It can tell you if it's there, but not why. So any research design, any research study, the way it's put together always has holes in it. You want to fix the difference being the teacher? I can fix that. You want to fix the difference being time of day? I can fix that, but if I fix one, I have to mess up the other. So every research study has its problems as you see the words like limitations and delimitations. Those are problems associated with the study. Or you'll see terms like threats to validity. So all research is bad research because there's no perfect research design. It's all bad. Some of it's worse. Our goal is to do bad research. Make sure it's not worse research. Can you handle that? You're going to have holes in your research. I'm telling you, you can't not. So, take it for what it's worth, interpret it for what you can, but don't overinterpret like you're going to see. I mentioned the commercials a minute ago. So understand the limits of our research. And part of that has to do with understanding the variables. Okay. Questions on this short part, mini section? I'm about to change over again.